This is our alternative aquatic battery project. The basic concept came from an actual dam where they generate the constant amount of power all the time. But when they have excess power, more than people are actually using, they're still generating the power, and so they need to do something with it, so they pump water back up. We did a project where you can take that same concept and put it on a small scale. So say you have a cabin out in the woods that has solar and wind energy, and what do you do with all that extra energy that you're generating when you're not using it? Normally you store it in batteries. The whole purpose of such a home would be to be environmentally friendly, and batteries are definitely not environmentally friendly. They have a lot of chemicals in them and they're really hard to dispose of. So an alternate thing that you could do with the excess energy is pump water up into a reservoir. So here we have our little pump down here in the water. And when you have excess energy generated by a windmill or solar panel, represented by our hand crank, then it powers the pump, and then water goes up into the reservoir, and then when you need energy, you can open a valve, and then water will flow down through the hydroelectric generator. When you want your home to be powered at the same time, you don't want that excess energy to be going to waste just because you have one light on and things. So you need to have a way to determine how much power you're generating, and if you're powering enough for just your home, or your home and the pump, or if your home doesn't need anything, should you just be powering the pump? So we did a lot of that logic in an Arduino, and that's in here. So we have our Arduino under here, underneath our display, and here's our display, which shows how much voltage is being supplied by which source, as well as the switch to the LED, whether it's off or on, the pump, whether it's off or on, and the valve, whether it's open or closed. We also have some relays in here which control which power source powers the LED and whether or not to power the pump and things like that. And then we also have some voltage dividers to protect the Arduino so that not too much current is going into it. We also have a limit switch which would be placed inside the reservoir. So if your reservoir is getting too full, it would push up against a floaty device and push up against the limit switch, which is attached, which we just have here. And when this gets pressed, then it stops the pump from pumping. One of the challenging things is to determine when this switch is on or off. It's an analog switch, it's a manual switch. It doesn't tell you, hey, I'm on. It doesn't send you some signal that tells you that. So what we did is we sent a probe digital voltage and said, be at this value, and then if the other side of it is at that value, then the switch is on. Otherwise, it's off. This project actually wasn't all that efficient. We got a efficiency of about 9%. Honestly, isn't that great. I think the main problem was because our hydroelectric generator wasn't designed for this scope of project. This actually wasn't even enough pressure to power the LED. We actually have to blow through the hole in the top to create enough pressure to power an LED at all. But if we had a larger reservoir that was clear up here and it had a lot more height to it, then it would work a lot more efficiently because it would be in the range that it was designed to function in. And we think the whole system is like that. If everything were designed together for a project like this, then it would all work together a lot better and you could get a lot better efficiency out of it. We also figured out that with what we got, it was about the equivalent to about a 3-volt battery, one of those little coin batteries. And if you wanted to power a 1 kilowatt power to a home for about an hour, it'd take about the size of a swimming pool reservoir of water. Some other ideas for future research would be to find out if you could do other mediums such as air, or if you could use a flywheel. It could also be researched whether pressurizing would be a good alternative, and instead of just pumping water up, also use energy to pressurize it, and therefore get better energy out of the hydroelectric generator. Some possible uses of this would be like in other countries where they need energy, but batteries aren't very good because they can get stolen and they are hard to transport, things like that. So this could be a viable solution.